so. All right, Ben. Let's start. Let me enable your screen. Yeah, go ahead.
Yeah, apart from new features, we just also want to know that if let's say that we have already configured link of 50 Gbps, some kind of, that link we upgraded to 60 Gbps now. So what might be the changes where we need to do? Because we are not in this is new for us, and those who got training. Sales is only here, and the Vikas is not in our department right now. So if this link capacity upgraded, what are the changes to be made in our Noxon's IRP? That also you have to
let me
ask you to cover.
Yeah. So let me see if I understood correctly. Some of the links you upgraded to a higher capacity, and you want to know what changes should be reflected, what changes should be done on the IRP site.
Yes. Let's say that link was 10G and now it's 20. So
yeah, okay, I will cover that as well. All right, let me enable the share screen. Let me know if you can see it. Can you see my screen?
Yes.
Okay, so there are not like a lot of changes since we talked the last time, but this is expected. This is planned to be the new front end. So we are moving away from the old front end, and that front end will be eventually deprecated in the next versions of RP, in a couple of versions of RP. So it will not longer be supported. So all of the heavy lifting, all of the changes in RP platform should be done, and I would recommend to be done via GMI. We're constantly working on, well, most of the stuff already has been migrated to GMI. There are just a couple of small things that have been not yet migrated to GMI, but if you're really interested and it's a huge priority for you, you can drop an email with a request, please move that functionality to GMI, and we'll give it a priority, and we will inform our devs. So what is the difference between the GMI and the old front ends? First of all, it's a completely new flavor, completely new colors. No kidding. So one of the big changes or differences between the old front end and GMI is that through a single panel, a lot of RP instances in different locations can be managed. In your case, it's only one instance, but if I don't know, Nepal Telecom is planning on deploying another instance, it will be done all via a single panel of glass. All of the information will be concentrated just in one front end. So instead of, let's say, instance statuses for one instance only, you will be able to see the components for the status of components for all of the instances that are currently running. Also, not to forget to mention, just like in old front end, this default dashboard can be changed. It can be customized according to your needs. You can move the widgets however you want. You can add new widgets, create your own, and just pin it here. And you will have all of the necessary information on the main page whenever you are logging into the RP or GMI. So let's make a quick run through for the RP functionalities. So as you know, RP is constantly probing outbound destinations in order to find the most effective way to reach it based on metrics, based on packet loss or latency. First, priority is given to packet loss, of course, and then to latency. And then RP through IBGP component injects those improvements in your edge routers. So all these improvements are done automatically by RP and can be seen here. So current improvements, and you will be able to see what RP did for a particular prefix at what time, to which AS and to which AS name and AS number, what metrics have been improved. So let's take, for example, 157.51.00/17. It was a packet loss improvement. The packet loss has been completely improved. So it was no connection to this destination, and now it's reachable with 0 packet loss. So it was moved away from Tata to Airtel IPT. Let's see if we have some latency improvements here. 37, 105, 128.0/20, Saudi Telecom Company. It was a latency improvement because it was improved from 181 milliseconds to 153 from Airtel IPT to Tata BRG. It's a latency improvement. Also here, it's an icon. You can hover it and it will pop up which type of improvement was done for that particular prefix. Just so you know, current improvements, it means that all these prefixes are currently injected into your router. So they will be there with a high local pref, either with split enabled. I will cover that in a short time. But these are the effective improvements. One thing also to troubleshoot afterwards if you encountered some, let's say, problems with a particular destination and you would like to see what RP has done for it. Here you can filter, let's say, for on the 25th, what improvements have been done by RP. And here you will see that for a particular prefix, 43, 128, 128.0/19, it was a latency improvement from RTL to China Telecom. These improvements, the history of improvements, are stored for an entire year, for the last 365 days. So it's pretty handy in case you had some previous problems. You can always go to historical records and see what RP has done for that particular prefix.
So this history will be for last 1 year, right?
Yes.
Is it configurable or is it somewhere configurable or
no, it's unfortunately it's hard coded. It cannot be changed.
Okay.
It's for 1 year.
So it's 1 year.
But it's more than enough from experience. I can tell. Usually,
yeah.
Whenever the engineers encounter any problems, they try to solve it as fast as they can. Maybe after a week, they manage or see that there was a problem then, and yeah, 1 week, 2 weeks, it's an overkill, to be honest, to keep the historical records for 1 year, but it's handy, it's there. Also, sometimes there are current problems, current outages for particular destinations, and RP maybe hasn't done an improvement because RP is doing probing based on traffic which is seen from flow, and maybe you have some destinations that are not generating that much traffic, and the thresholds in RP has not been reached, and that let's say destination was not improved, or it was probed, but the RP considered that an improvement could not be done for that prefix. So for that, there is a report, very handy, probes today. You can go here and you will see for the last 24 hours what were the packet loss and later what were the probing results for this particular prefix. Here you can add more providers, so it will take a little space, but you can see what happened. Okay, so Google Singapore, Google Daily, I'm pretty sure those are partial providers. China Telecom, okay, is it a transit? Oh wow, has a lot of 100 per packet loss. So I believe this one is a transit provider here. So let's see. This prefix was probed not long ago. Which IP exactly was probed from that range? This is direct probing. To which AS it belongs. Okay, so the probing was successful, and even better, it was improved. This prefix it was a retry probing. Okay, I will mention that as well when we will cover the core component. And it had 0 packet loss and such latency on RTL. It had a little less with less than 1 millisecond difference from the last transit. Here 44 milliseconds, here 48. Okay, so this is a perfect moment to talk about the thresholds. RP has configurable thresholds for packet loss and latency improvements. If those thresholds are not let's say, okay, so a threshold for packet loss and for latency shows when RP will do an improvement and when it will not. So by default, the packet loss, relevant packet loss is 3%. So what does it mean? If the difference on between the probes is less than 3% packet loss, RP will not do any improvement. So in this case, we have 0 packet loss here, 0 packet loss here, 0 packet loss here, and 0 packet loss here. RP will do absolutely nothing. If it would be a packet loss improvement. If the packet loss is completely equal on all of the providers, it will attempt to do latency improvement. So it will look at the latency metrics. For packet loss, it's only the percent threshold. For latency, it's a little bit different. It's actually 2 conditions that have to be met. So by default, I think it's 7 milliseconds and 7%. Oh, no, sorry, it's 10 milliseconds, 10%. So what does it mean? RP will do an improvement if the difference between the old provider and the new provider is at least 10 milliseconds, and at the same time, the difference in percent should be more than 10%. So here, it will basically
so yeah, you mean that let's say that Airtel IPT BRZ 48G, this 48 millisecond first one. First one, and then the other one is, let's say that this is yeah, it is 47, but let's say it's 37.
37.
So in that case, that outgoing traffic will go from Airtel IPT.
Yeah.
That will, yeah. Otherwise,
yes.
If it's 47, then and initially
it will do nothing. Yeah, in this case, it will do nothing because it's too less. There is no sense to change it from 48 to 47. Okay, if I already talked about that, I can actually show you where these thresholds are configured. So it's not these are not the the default settings. So here, relevant RTT difference, it's 8 milliseconds. And at the same time, it should be where it is relevant RTT difference 5%. So in that case that you mentioned, RP would do nothing. But if the RTT difference was more than 8 milliseconds and more than 5%, then it would change the traffic. Also, the packet loss, which is the first metric being taken in consideration. Yeah.
So it's or condition or and?
And it's not or.
And okay.
It's and. Yeah. So how the rerouting decision is being taken? So there is a priority. First, it's being checked for loss, and then it's checked for latency. And here, yeah, it was configured for 2%, which means that if the difference between the old provider is and the new provider is more than 2%, then RP will do an improvement. If it's less, then it will leave it as it is. What else could I show you here? Okay, monitor history. It's pretty straightforward. Just so I know if I should talk about or not, should I talk about external and internal monitors? All right, I think I'll talk about it either way. So RP has two fail safes in order to avoid creating a black hole for outbound traffic. There could be cases when RP would push an improvement, let's say to where it is, props today. Okay, so it pushed an improvement from Airtel IPT to Airtel IP. Okay, it's the same, but from 58G to 30G. It pushed an improvement to this second provider, and something happened on this link. Let's say the eBGP session went down. RP constantly checks the status of the eBGP sessions on the router, on the edge router. So in case the eBGP session goes down, RP will detect that via SNMP and will withdraw all the improvements from RT IPT. So in order to avoid a black hole. Also, at the same time, this is called the internal monitor. Also, at the same time, RP has the second failsafe called external monitor, which means that RP constantly pings from the probing IP for Airtel IPT, Google DNS, and Open DNS. Either one of that has to respond to pings initiated by RP. In case neither of those DNS servers respond, then RP will consider that the provider is failing and also will withdraw the improvements. And as soon as the internal monitor and the external monitor are okay, the improvements and the probing is being done via the provider. In case either one of the monitors goes down, RP is withdrawing the improvements.
Okay, just can you just explain us that external monitor you are just explaining?
Yeah, so let's take for example,
Mm.
external. Let's take for example, we'll log into your server. So you have a better understanding. Come on. Okay. Makes sense. Okay, so you have these IPs but I will need only the master IPs. Master. Yeah, let me do even better. Something like this. Name. Okay, here. So a probing IP is an IP address, a public address. It can be either a public address or it can be a private IP address, but it has to be not at one-to-one on a firewall or the edge route. It doesn't matter, but it has to be internet routable. So these IPs are used exclusively for probing. Why every provider, why every link needs a probing IP is because on the edge routers, on your edge routers are already configured PBR policies, policy-based routing policies. Those are specific route maps that force the traffic from such a source IP to go all the time via RTL, IPT, BRG 58G.
Okay. I got your head cut. Yes, I understand.
And okay, so to cover the external monitor, what does it mean? So in order to confirm that the internet is reachable via this link, RP constantly pings either Google DNS, either OpenDNS from this source IP. And if it sees that there is responses back from those servers, from those DNS servers, it considers this that internet is reachable via this link and everything is fine. And it can be and the traffic can be improved via this link. I hope that I answered to your question.
Yeah, I understand.
So,
Okay.
hello. So if we added new circuit, then we need to add separate separate then probing IP. Yeah?
If you're adding new links,
circuit,
new circuits,
circuit,
yes, you need to add a new probing IP. In your case, it's actually not just one, it's two, because you have a failover. So I think it's slave probing. Here. So for the same for the same link, there are two IP addresses. So this one is on the master server. It's configured here. You will be able to see it. Yeah, it's here on this interface. And the other one is on the slave server. But all of the configuration is being done only on the master server. But from these IP addresses, they are reaching the same provider, just from two different servers. But if you add a new link, you need to to give two probing IPs. And I can actually cover also the RP requirements. If you are adding a new circuit, you need two probing IPs. So two IPv4 IPs. If this provider is also IPv6 capable, then four IP addresses, two IPv4, two IPv6 addresses, two for master, two for slave. If it's that link is connected to a new router, also we will need, of course, SNMP read-only access to that router. And last but not least, flow to be enabled on the outbound and inbound direction on that interface connected to the provider, because RP needs to know constantly what traffic is there and how many throughput to certain destinations is there. Okay, so these I would say are the most important reports in GMI. Here it's more like all the statistics, like prefix statistics, AS statistics, but they pretty much look Very similar, just different information. So for prefix statistics, of course, there would be here a prefix. For AS statistics, it's actually the AS, how much volume, how many improvements to that AS have been done, the such statistics as outbound megabits per second, 95th for a month. This is done. This is calculated monthly.
So this volume is 24 hours or what? That prefix is that AS status.
No. AS statistics. This is for the last month. Here, you can see the
Last
till
month.
last month. Yeah, it's done the last month, and 95th, of course, is calculated every month. I think you can change here the, but not for the AS. AS, I'm pretty sure it's hard coded only to be calculated monthly. Top volume prefixes, if you need some basic information to which prefixes you have the most outbound traffic. Okay, makes sense that it takes a little time to load this here. So the most traffic goes to 142, 250, 00/16, 33 petabytes. Okay, that's a lot. And it's Google. Okay, makes sense. Could be YouTube, pretty much, if it's so much traffic there.
Just, yes. Yeah, this volume means inbound, outbound total, right?
Monthly. I think it's monthly as well.
No, it's monthly, but it's in and out both, plus sum of in and out, right? The volume.
No, I think it's not only for outbound. It's outbound traffic.
Outbound means coming from that AS to our network.
Let me think. Actually, yeah, you're right. It should be sum of inbound and outbound.
Some, I think, yeah.
Country statistics. Maybe you are interested in that. Exchange statistics, it's pretty much absolutely the same information, but just for different types of information that you need. Exchange statistics and so on. Also, RP has an extensive list of graphs. More interested, at least for me, it's like bandwidth usage per provider. Yeah. So maybe total bandwidth usage if you're interested in how overall traffic you have. So here, what is it? Inbound, it's okay, it's a lot. 106,000 to 0100. Okay.
Yeah, just
Outbound.
in your graph, many places there is 95th. So what does that mean? 95th.
95th is the actually, it's the monthly value. So for out here, it's 32 gigs. For in, it's 140 gigs. It's 95th. It's the, let's say, the average level of traffic that you have during 1 month. It's absolutely the same type of 95th as in the agreements you have with your providers. But here you see the effective your 95th. But with providers, they tell you what 95th you have per agreement, and you cannot go above that 95th, correct? Bandwidth usage, providers bandwidth usage. Also very handy. You can see the 95th values per provider. So here on, let's say on RTEL IPT BRG58, this is the outbound traffic. So this is pulled from a SNMP, so it's very accurate. For inbound, sorry, this is inbound. So this is at the top inbound, at the bottom is the outbound. a little bit more than 5 gigs, and total inbound and outbound. Inbound. Okay, about inbound, I will cover it a little bit later because that is when we will talk about the new features. So routing policies. In RP, you can set allow, deny, and VAP policies. What they mean? So sometimes you want to force RP to do improvements only via particular links. You wouldn't like RP to move traffic away, let's say, from internet exchange to transit providers or to policy providers, and everything, all of that is done in this page. So you give a prefix, either a SEN or even the country. You choose which type of policy it is, or an allow or deny policy. Static and static exact, I'll tell you in just a couple of seconds later. What kind of prefix? Let's say something like this. Next, rerouting allowed through only Airtel and Airtel IP through these two transits, or even Google, because it's a Google prefix. Local improvement only. This is more specific. If you have, multiple locations, but that are nearby, if taking into consideration the region, they are in the same region, or two neighboring regions, and the latency is no more than 60 milliseconds, you can actually add both of those locations as to be managed by only one RP instance. But in your case, everything is only in one location, so you don't have multiple routing domains. So this one, it's not necessary, but here the AP probing. Okay, so any allow or deny routing policy can be VIP enabled, let's say. Sometimes you have some destinations that you wouldn't like only to be allowed or denied through certain links, but you would also want to be probed more often than the regular probing. So by default, the regular reprobing period is 4 hours. So let's say you have a prefix, RP has done an improvement for it, so it has to verify that the improvement is still relevant every 4 hours, and it will do this reprobing constantly. But some destinations, maybe some very important destinations, can be forced to be reprobed not every 4 hours, but every hour or every 45 minutes. All of this can be configured in RP as well. So we talked about allow and deny. Here, sometimes you would like to create a static route, and you can do this by not logging on into the routers itself, into the edge routers, but you can actually do this from RP. So you just write the prefix. Oh, sorry, 24. So this will not be. You create a static route, and it will be you are choosing through which provider or through which next hop you would like this prefix to be forced. And when you hit next, it's advertised automatically to the router. One thing to point out: if you create a static route, this prefix will not be probed. It will be just forced via the provider that you chose in the past. Also, just a little bit, just a small difference.
So we can delete also.
Yeah. But after
Yeah.
you create the static route, you can delete it from RP. If you created it in RP, of course, RP cannot influence the static route on the router if it was created there. Static is allowed up to /24. Static exact, you can actually choose a particular destination to be rerouted through a certain provider. It's just that, yeah, here static is only up to /24 and exact is a /32 destination. Flow spec policies. So if for routing policies, it changes only the core behavior and the static routes are using the BGP component, there is additional capabilities for BGP called flow spec policies. So these are like rules that can be remotely triggered from a certain platform. In this case, is RP, because we support it. You can add a new rule and you can create really awesome policies. So let's say slash even exact. You want to create a policy flow spec 80 for port 80 and 443, let's say. However, this is useless because it's actually 53. It's a DNS server, but you can choose what type of transport protocol to be this policy. You can choose the destination prefix, you can choose the source port, you can choose even the differentiated services code point, and you can either throttle or redirect to traffic from a certain source or to a certain destination to be routed via a particular next hop, or you can throttle, so you limit it to a particular threshold of megabits per second. So redirect and redirect IP, it's the same, but we're just using different flow spec types of policies. Or you can even create a flow spec policy that will drop the entire traffic to a certain destination if the traffic is sourced from inside your AS, or you can mitigate manually with DDoS also from here. But we actually created a feature which I will show you a little bit later. Troubleshooting tools, pretty sure that everyone is familiar with Looking Glass, Traceroute, Whois. So this is mostly just parsing the outputs from the server itself, from the Linux server to front end. Just a little difference. Let's say here there is a very nice and very cool feature that we have for Traceroute. It will take time because you have a lot of links, not just two, so it will take a while, minute or two. Let's wait for some time.
What is the default configured probing time? That probing
It
there
depends.
Any,
It depends because you can imagine different destinations can be reached in different amount of time, if taking into consideration even the latency, and not only. So there are particular algorithms. So let's say for direct probing, if this destination, let's 8.8.8.8 responds without any problem, then the direct probing algorithm kicks in. which means that RP just is doing pings, and that's all. But also here applies two rules. If so by default it sends only 5 packets. So let's say there is an ideal situation in the world through all of the transit providers, all of the partial providers. Okay, you have Google as well here. You have 0 packet loss through all of the transits. Okay, then in this case it will send to each provider only 5 packets. It means that it will take not a long time. But sometimes there is packet loss. In this case, RP for those providers where it sees actually packet loss, it will issue another 95 packets. So 100 packets in total. If in those first 5 packets it discovered at least one with packet loss, in order to calculate correctly the packet loss metrics. So imagine that you have one packet with packet loss and it issued another 95, so it will take even a longer time. This is direct probing. For indirect probing, if sometimes certain destinations cannot be reached to this particular IP address, okay? Then RP uses indirect probing. It attempts direct probing. It sees that none of the IP addresses from that range does not respond to probing, to pings, and it attempts to do the indirect probing. Which means it starts a trace route, and you can imagine the trace route it increments the TTL, so also it takes time. It makes trace route to 4.8s. 4.8s could be unreachable, but it will see the next hop before that. So because 4.8s, it has before 4.8s, there is a router. Definitely there is a router. So it will base the metrics on the trace route to that next hop before the final destination. No wonder it takes long. You have a lot of providers, to be honest, but I can show you that RP is actually doing something in the background. Sorry. Here, yeah, I forgot that this is as well. But PBR and the external monitor is based on that. Let's see. Actually, I can do it this way. Really? I'm missing something. Oh, it's not probing, of course. It's just a trace route. Oh, really? Okay, let me actually show you. See that? No. Always forgot which is the first word. We have only two providers, so it will take not a long time. All right. So as long as it's making the trace route from our instance, here there is the prefix probing. So RP does everything automatically, but there is sometimes when you want to troubleshoot a certain destination. So you would like to actually see what are the metrics for it. You can, oh, didn't choose any. Don't have RD, so it's only RD1 probe. So now it should be something here. Probing is already in progress. Okay. So here, just regular trace route, nothing special, but considering that we have a probing IPs and we have the PBR policies, it means that the same destination is being reached via two different ways. So where is this cool handy feature here? Absolutely the same, but with more information. The same destination is being reached. So this is our IS. This is going, so from two different probing IPs, you see that we have Orange, we have StarNet. From StarNet, okay, it goes via 86, 104, 125, 85. Okay, I don't recognize that prefix, unfortunately, but okay, we have also Orange. So it goes through Orange Moldova, goes through Orange Romania, and then they have the peering with Google LLC. So here it's completely two different traces, but reaching the same destination, and you have even the metrics here. Pretty cool. But for you, yeah, you have like 20 connections or how many, and I think that maybe the graph uh, gave an error. So let's see, okay, yeah, it's gonna take a while. We'll cover that a little bit later. Okay, this is the main page, I would say, for us engineers. Here is where the magic happens. Here's where all of the parameters are being set and all the tweaking is being done. So in global, there are two different modes in which RP can work. There is performance mode and there is cost mode. So performance is makes the rerouting decisions based only on the metrics, on packet loss and latency. But there are clients that are interested in cutting the costs for the links. And in the cost mode means that RP will give first priority to packet loss. Then for every provider, there is a setting cost per megabyte per second, I think. And RP chooses the cheapest link. So it makes the routing to the cheapest link, and then it makes the latency improvements. In your case, it's performance, so you're interested, sorry, only in performance optimization. Of course, RP supports IPv6. Also to mention, maybe sometimes you will encounter routing loops. It happens. Maybe misconfiguration, you added a new link, or something happened to your routers, or it doesn't matter. But RP has not been configured before that, and some routing loop happens because of RP. Well, it happens. So you can switch the RP instance to non-intrusive mode. So, okay, there are two main modes in which RP can work: non-intrusive and intrusive. What is the difference? In non-intrusive mode, it is doing only the probing. So you'll basically see all of these graphs and reports, but none of the improvements are really injected into the router. So this is non-intrusive mode. So BGP daemon is not active, let's say. Intrusive mode, all of the changes, all of the rerouting decisions that RP has made are actually injected into your routers. So in case you would like RP to stop doing any improvements, you can go to RP, and instead of shut downing the instance, you can just hit the non-intrusive mode, hit save, and RP will stop to do the injecting, but will continue to do the probing. As soon as you hit the intrusive mode back, RP with the new information injects the latest improvements. Okay, what else? Flow spec. So as I mentioned before, you can inject with flow spec rules. So either enable, disable, or flow spec capabilities. Ignored prefixes and ascend, pretty handy section. Sometimes you would like some destinations to not be improved at all. In this case, you can just add a prefix here, or mark those prefixes on your routers with specific BGP communities. And as soon as RP sees from BGP those prefixes with those communities, if they're added here, RP will completely ignore and not do any probing and improvements for those prefixes. Also ignore SN. You just type in the SN, and all of the prefixes for that SN are completely ignored. Ignore and announce prefixes, also a very handy feature. Sometimes some clients are very interested in making improvements only for those destinations that they are receiving from the transit provider, from all of the links. And you have to re-advertise those links to RP. And in case those prefixes are not present in the BGP table, in the IBGP table, then RP will do nothing for those prefixes with that feature enabled. If it's disabled, RP just looks in the own database. Routing domains, this is only for multiple routing domains. If you have, I actually mentioned it before, if you have multiple data centers in different locations that have some particular distance between them, but the latency between them is no more than 60 milliseconds, then RP can do improvements and manage multiple data centers.
So this RD routing domains, where to configure RD2 or something, if there is RD2, RD3, some, and where to configure
it's here.
those.
It's configured here.
Okay,
so you add an RD2 and but yeah, it needs investigation first of all. It needs additional configurations on the router side, because RP in this case does two types of improvements: local improvements and global improvements. So sometimes an improvement should be kept only in that routing domain. So let's say you have, I don't know, 2 cities, and the inter DC or inter DC latency is 30 milliseconds. So it makes sense when an improvement should be done locally, or should be done only in one of the cities, but it should not be done in the other city, because of this 30 milliseconds that are adding up on top of the latency. But sometimes if the packet loss is 100%, the traffic can be shifted from one city to go via your internal link, and to be routed via the other city. So basically the connection is not impacted.
So here in routing domains, we need to add routers or something.
Well,
so this is
you
just
have
this is just the name, right?
So in order to isolate those global improvements you need RP needs to tag those improvements with BGP communities, and the routers have to filter those prefixes with those communities. So it makes sense that in one routing domain you have two routers, and in another routing domain you have absolutely two other routers. So yeah, every provider is tagged with its own routing domain. So it's either in routing domain 1 or routing domain 2. And based on that, RP differentiates them. BGP here is where the routers are being added. So wow, here you have a massive number of routers. Okay, I can actually mention how RP makes the improvements. So after you added the router, you need RP improvements to have priority over the routes that you receive from your transit providers. So in order to override those, RP either advertises the routes with a higher local pref, so they become best, and they in this way the improvements are actually applied on the routers, and the traffic is actually routed to the most efficient provider. So this is one way. Either there is a feature called split announcements, which means that, let's say you have a /20 /24, yeah, and instead of managing or making the route best through local improvements, through local
Difference.
RP actually, yeah, local preference, it actually injects that /24 as 2/25. It splits the prefix in half, and because it's the longest prefix match, it becomes the best. And the original routes and the aggregates that are received from the providers are still there, still staying there. Yeah, that's pretty much it on the routers. Here it's just very basic stuff like autonomous number, RP's address, local pref. Sometimes BGP can have a password. If you would like to tag the improvements from a certain router with a certain BGP community, which you do. Okay, for inbound and for blackhauling. I will cover that a little bit later when I will talk about blackhauling. Okay, collector. Here are the thresholds for what prefixes, outbound prefixes, are added automatically in added automatically actually for probing. Sometimes there are prefixes which have minimal traffic, and there is no sense to probe that. So here are the thresholds that are being set for the traffic. Analyze prefixes. Here I added your prefixes and sometimes the prefixes belonging to your downstreams. So RP actually filters the flow based on the source IP that is seen there. So if it sees that that traffic going outside is sourced by your prefixes, then it validates those flows and it injects those into the database. Basic configurations for NetFlow UDP port and SFlow, Spandy, but you do not. So there are two ways on how to feed RP with information, either flow feed, or you can configure span ports on the routers and send mirror the traffic to the RP, and it will know which destinations to probe. Inbound prefixes. Okay, this is the section where the inbound prefixes belonging to EIS are configured to be used for either inbound commit control or inbound performance optimization, or even both at the same time. So this is where the prefixes are being configured. and based on that, RP knows how to handle the prefixes in the case the 95th value for inbound traffic is surpassed, or if RP finds a potential problem on the inbound traffic. But I'll already draw here something to explain the inbound performance optimization, because it's a tricky theme to discuss. Okay, core. Actually, I showed already the relevant RTT difference and the packet loss. One of the most important parameters that I can discuss in core of max IPv4 improvements. So this is the limit which caps the core component of RP. So in case RP will do 30,000 improvements and will reach that limit, RP will not do any new improvements. This is a cap, a threshold for RP. Same thing applies for IPv6. Very probing period. So this is the amount of time in which RP reprobes the improvements that have been done. I actually mentioned before. So if RP has done an improvement, it needs to validate it a little bit later in order to confirm, okay, this improvement is still valid. I should still keep it on the route, or should I remove it, or should I route it to another provider? So this is the amount of time that RP waits for a particular prefix to do the reprobing. A VIP reprobing period. So you have some special destinations and you would like them to be probed more often, and it will do it every 1200 seconds. Okay, this is more specific stuff. Okay, outage detection. RP has the ability to detect problems on the way to a particular destination. Sometimes there is no problem on your side or on the link connected to your transit provider, but it's somewhere along the AS path. So if RP does the trace route to a particular destination, it can actually see sometimes that between two ASs there is a problem. And in case it detects that there is a problem there, it will reprobe all of the prefixes that has that particular AS path that has been injected into the router, and will confirm that there is a problem and will attempt to change the prefix to be routed via another IS path. Commit control. So for you, it's enabled for inbound. Okay, for inbound and commit control. I see. Okay, so commit control for outbound. Sometimes you need to keep a particular amount of traffic for outbound or inbound. And RP is able to help you with that. So for outbound, it will see that the traffic or the traffic capacity is being reached, and it will start to route traffic away from that link, with the condition that there is enough bandwidth on another link. So it will do this automatically for outbound, because it has, okay, it can do it with the help of 900,000 routes. So it can be done pretty granularly. Even more for outbound, you can do load balancing. For inbound, the regular prepend policy is being used. So RP can detect as well for inbound that the traffic capacity is being reached. In case it's being reached, it will start prepending your own prefixes via that overloaded provider, and this will potentially unload this link, and the inbound traffic will be rerouted via other links. In case the capacity of all of the links is already reaching full, unfortunately, RP will do absolutely nothing because it doesn't have spare room on other links to change the traffic.
Can you move down? Just
Yeah.
Yeah, this yeah, you can just up one line up. This configured 95th for inbound, and then configured 95th. Both are same, right?
No. So for inbound, you can configure it separately. Configured 95th, it's for outbound. Configured 95th for inbound, it's for inbound. Okay.
So yeah, it's not mentioned outbound, so it's outbound, right?
Sorry, say again.
Yeah. In one it's mentioned configured 95th for inbound, but in other
No,
it's not mentioned.
It's not done for 1 year. It's done for 1 month. Even more. You can set up RP when it's the billing date or and from which day the 95th should be calculated. So it's either the monthly 95th. Okay.
No, what I mean is that yeah, in one column it's mentioned that configured 95th for inbound, right?
Yeah.
But in another it's just configured 95th. There is not mentioned outbound or inbound. So that is outbound, right?
Yes,
If that
this
is
is
not mentioned,
the second one is outbound. Yeah.
outbound. Okay, and this we can change here. If you click here, I think we can change here.
Yeah.
Yeah.
Can be done
So what is
even here
the
directly.
standard that let's say that our link is 10 Gbps capacity. So what is the standard?
It depends on your
80%?
it depends on your preferences. If you
Preferences,
like
okay.
so if you're interested on the outbound traffic to be kept under 8 gigs on a 10 gig link, it's no problem. You can here put it 8,000 and it will be in the
8 gig.
traffic. Yeah, and the
8 gig.
traffic download will start at 8 gigs.
So this is where we can control those, that right?
Yes.
This is the yes.
One thing that I actually see here,
Yeah.
for outbound and for inbound, unfortunately, unloading is effective only on transit providers. Okay, for outbound on internet exchanges and on partial, you can take away those prefixes to be routed via transit or via another partial or via internet exchange. For inbound, because the prepending is being used, it's definitely not effective on the internet exchanges, and I think they have route maps that strip the prepends. So you can send even 1,000 prepends via the internet exchanges. It will make absolutely no difference because the route maps just remove them. Also, same thing on the partial links. If you send with prepends, then why you connect it directly to Google? Doesn't make sense. Why you should send prepends there?
Yeah, and another thing I want to say, yeah, in 95th mode column, this third column.
Group.
Yeah,
You mean this one?
Yeah, no, third column.
Oh, third.
95th
okay.
mode. Yeah, third third.
Oh,
Yeah,
this one.
yes.
Yeah.
You can see, yeah, there is in some row it is separate 95th for in and out, and another you can see 95th from greater of in and out. What is difference? What is difference in both?
To be honest, I'll have to look it up myself.
No,
Usually,
you can see in one row it is in Airtel.
Yeah. Just give me 1 sec. I'll tell you exactly. Haven't played with different types. Just give me 1 sec. Okay. So for separate 95th for in out is the mode in which RP calculates the 95th. So it can be done separately. So there will be different 95 for inbound traffic and different 95 for outbound traffic. They will be completely separate when it comes to calculation of 95 for 1 month. Okay. Okay. For 95th from greater of in out, at each time point, the greater of inbound or outbound bandwidth usage value is used to determine 95th. So sometimes the 95th is higher for inbound traffic. In this case, RP will calculate the 95th based on that value. Sometimes the out is higher, 95th for out is higher than for in. Then in this case, RP will calculate 95th based on the value of out 95th. And greater of separating in and out 95th. It's the 95th that are the 95th of those are determined separately for inbound and outbound traffic. But the larger value is used to verify if commitment is met. So it's calculated separately, but RP constantly checks according to the highest value of the current 95 on any link, on that specific link, sorry. But usually it's separate and default value is separate 95 for in out.
Yeah, in here below you can see it is 95th from greater of in and out. Airtel BHR. Airtel BHR. Yeah, yeah.
Yeah, I don't know who configured that, to be honest. Maybe it was just misclicking, or I don't know.
Okay. Okay. So if in this way we configure, then yeah, inbound and outbound we can put it separately, right?
Yeah, you can just hit it here and it will be separate. But the value that is here, the 95th is calculated from the highest value. So if you have more, yeah, and you have more inbound, I think here, yeah. So, and the current bandwidth usage,
Okay.
it will be calculated from inbound.
Uh,
All right. Okay. And yeah, and this is the control panels for commit control and inbound commit control. Here's where you enable and disable the features, basically. And yeah, some very specific parameters are being set. Inbound. Inbound performance, I will talk about it a little bit later. Okay, trace route, sorry, Explorer. This is where the Explorer component is being configured and which probing algorithms are being used. So for probing algorithm here, RP is attempting to do a trace route or pings with that particular algorithm first. So here the priority is given to ICMP. So let's say RP tries to probe Google DNS. It probes it first with ICMP. Maybe Google DNS has some filters. It will not respond. Then RP will attempt to do it with UDP packets. And if those do not respond as well, it will attempt to create a TCP session in order to still pull some metrics for that particular destination, and based on which to do an improvement. Traceroute algorithm. This is what other transport protocols used for reconstructing AS path. So sometimes RP cannot see from BGP the AS path for a particular destination, but it can reconstruct it from traceroute. Then based on traceroute, it will it will change those IP addresses in the trace route to which AS it belongs, and based on that, it will reconstruct the AS path, because you cannot inject an improvement, a BGP update, without an AS path.
But yeah, all I think it's disabled, right?
No,
Upon
no, no,
probing
no. It's
algorithm.
very enabled. So the TCP SYN is disabled. Okay, I can do it like this. Just give me 1 sec. Okay, here is disabled. So it
Okay,
shows
okay.
disable. It's not, but
Okay.
disabled.
Okay, okay. So okay, I understand. So it is a new.
Yeah.
Mhm.
Give me 1 sec. Okay. Infrastructure IPs. Sometimes you made some changes on the connection between the RP and your edge router, and RP needs to know which other routers or all three devices in its path in order to know where is your inside network and where is the outside of your AS. So here all of the hops should be added. So this is pretty basic. It can be just done from a trace route, from a probing AP, and until the edge, you just add those IPs as /32, or you can even add the infrastructure IPs and as a /24, and it will take and all of the diag hops between RP and internet. Oh, and sorry, your edge router will be neglected. Okay, providers. This is where actually the providers are being configured, added, and the threshold, different thresholds are being done. So you were interested in, if you upgrade a particular link, what changes should be done on RP side.
Yes.
Okay, sometimes you maybe migrate the link to another router in the same data center. Then you need to change the router here, delete it, add it, or maybe you added another double peering to the same BGP peer. You add here a new router. So this is what should be done if you change the link to another router. Flow agent. If maybe you changed, but on the same router, the link from a 1 gig link to a 10 gig link, or from a 10 gig interface to a 20 gig interface. It's a completely different interface, which means it will be a completely different flow agent. So it should be adjusted here. So it means it should be deleted here, and the correct interface should be assigned to this provider. Also, maximum load. If you on the same link, or you change the links, or you need to change the maximum load per interface. What does it mean? RP needs to know how much capacity a particular provider has in order to not push improvements when the link's capacity is being reached. So sometimes it happens that nobody configures this, so it's blank. RP will allow that, but in reality, RP can push improvements when the link's capacity is already reached, and a lot of traffic will be dropped. Maybe you reduced the traffic capacity, so you would also have to adjust this value. If you increased, you will need to configure RP to know that, okay, you can do even more improvements there. So it's not a problem if you will.
So here is RD1, right? So which link we should consider in routing domain 1 or 2? Yeah, you can see. Yeah. That this here also another configuration for routing domain.
No, you
RD.
have only routing domain, one routing domain.
So
So
if there is
here,
two,
yeah.
then we need to change, right?
Yeah. So if it's in another location, you first create the routing domain, and then when you add the providers, or maybe you migrate it to that routing domain, you change it. So yeah. Okay. IPv4, well, pretty basic here. What is the next hop of the provider? Which probing IP, which I mentioned, what IP addresses, what IP address has to be used for probing via that particular via RTL IPT in this case. Provider SN, route and next hop. Okay, IPv6, maybe it doesn't have IPv6. You don't have a eBGP IPv6 connection with this provider. Commit control. So here, okay, some information sometimes is doubled. So, oh, actually not here. Okay.
So can
In
we
the old front end, there was this maximum load per interface. It was also here, so it was just duplicated. But this is the amount of traffic that you would like to keep on the link. So you have a 58,600, but you would like traffic to be 4,100 or 40 gigs. Here you configure 40 gigs, and even though the improvements can be done, RP will start rerouting traffic from this link if it hits the 40 gigs capacity.
So yeah, just one question. So this parameter we can change from to, I think there is another commit control, right?
Yeah,
from
it's
yes.
absolutely the same. Either you configure it there, or you can
that will be replicated if I configure in one place, that will be replicated in another, right?
Yeah, it will be reflected in the So if you configure it here, it will be in the provider section as well. After you hit the save button. You can change the centile value. Okay. Precedence. Commit control. If it's enabled, disabled, you can enable per provider. It's not a problem. Provider's billing day. Okay. So I mentioned before about the 95th value and the billing day. If you want RP to keep the traffic level based on the monthly 95th value, let's say you have a 40 gigs capacity link, and actually let's take RTL as an example. So you have a 60 gig link, and the 95th percentile is configured 5800. So, but the actual 95th is 60. Sorry, this is confusing. Okay, the link is 60, but the 95th is 58. So if you configure a provider's billing day, one or the second, it's the date in the calendar. Yeah, the date in the calendar. It means that RP will calculate the 95th and try to keep the traffic level under 95th based on the monthly value. It will. So let's take, for example, here 5800. The traffic capacity hit the 58. It went even more, 60, 62, 63 gigs, but the 95th value has not been fulfilled yet. Just so you understand that, let me go to the graphs. Bandwidth usage per provider. Here. Uh, Okay, no 95 here. I remember that it was somewhere.
Provider bandwidth versus.
Okay, so here, you see you have here current 95 value for monthly, calculated monthly. So sometimes traffic, if it's set to a particular day, it will allow traffic to go over 148 gigs. So it would go to 155, 160, maybe 167, because overall per month, the 95 value has not been fulfilled because it's calculated for the entire period based on the peaks and on the lows. So it's taking into consideration and calculating the average for the entire period. So let's say at the beginning of the month, it will keep the traffic at 160, 165, and then it will see that it hits the 95 value per month, and it will start really hard to decrease the traffic throughput on the link. So this is one of the ways how to keep the 95, because the 95 was not overcommitted. It's still 148, correct? But if you set -1, it means that at the exact moment when the traffic is being reached to 58, RP will start heavily unloading traffic. It doesn't calculate it for entire month. It just sees with 58. Okay, I need to unload this traffic right away.
Mhm.
I hope it makes sense.
Yeah.
Okay. SNMP. So here you configure to which physical interface this provider is connected. External monitor, as I mentioned before, RP constantly sends ICMP UDP pings from this particular probing address to DNS, Google DNS or Open DNS in order to confirm that internet is reachable. In case it's not reachable, in case neither of these addresses are responding, then RP will withdraw the improvements made to RTL IPT. Internal monitor, this is okay, so RP is doing SNMP walks on the router and can see the status of the eBGP session. In case it's down, RP will withdraw automatically the improvements. Inbound communities. Okay, so you have actually the inbound configured. So for commit control, RP for inbound commit control uses prepends, correct? But the prepending is actually done by your routers. So how RP actually does the prepending? RP sends your prefixes with a particular inbound BGP community that's been agreed with you before, and there is a route map generated and applied on your routers. And when it sees your prefixes with this BGP community, it's doing a certain amount of prepends. So this is the base community. We call it the base community. So in case RP, so in case your prefixes or your links on inbound are not overloaded, RP will advertise your prefixes with this community, and this community means no prepends. If RP sends with this community, so here we set up only the base community, and based on the prepends, it just increments it with 1 digit. But this is done automatically in the background. So when RP advertises with this community, it means that your router will prepend that particular prefix with 1 prepend. If two, with 2 prepends, with 3 prepends, and so on up to 7. So 7, but 7 is not used, so only 6 prepends is done from RP side, can be done automatically from RP side. But here it's only the base community. But as soon as you give this base community RP, in case the link is overloaded, we'll increment it automatically in the background. Flow spec. So this flow spec is done for all the flow spec rules sent from RP. Black holing. So black holing, I will explain it a little later. In your case, you have a file over server, so it means that RP needs to be configured with 2 probing addresses. So this is on the main server, on the master server, and this is the probing on the slave server. And just like I mentioned before, all the configurations is done only on the master server. There is no need to go to 2 different servers and configure two related things, but 2 different pages. SNMP host. So just like I said, RP constantly checks the BGP sessions and not only the counters on the interfaces connected to the providers and pulls information. So here you configure basically the routers, the SNMP hosts. It supports v2 or even v3. Notifications. So here are the thresholds for setting up RP to send notifications. So you would like to know and receive notifications either on email, or you can even configure SMS channel configuration or webhooks. So far has been confirmed with Microsoft Teams and Slack, so you can even receive those on chat. SNMP trap channel configuration in case you have SNMP monitoring server. And here you set up the amounts when RP is triggered and sends the notification. So for notification, they are per user. So you set up here the thresholds, but in order to actually receive the notifications, you need to subscribe to those notifications. So here you go to your user notification, add a subscription. Here's an extensive list of what type of notifications, in which cases you would like to receive it, and you set up per user for which instance, a short description, the interval. Let's say, doesn't matter what type. So if a circuit goes down, you would like to be notified, and then you set up which type of sorry, got my phone calling. You'd like to know to which notification channel to receive those notifications. Okay, threat mitigation. Let me actually talk first about the new features that we've added in the 2 last major releases. Okay, so I talked about inbound community control. I talked pretty much covered everything except the 2 latest features that we added in RP. One of them is called inbound performance optimization. How it works and what are the requirements. So let's take this example. This is our Noction AS. We are dual homed. We have 2 ISPs. One of them is StarNet. One of them is Orange. We have an RP instance here. This is our AS. And this is our prefix that we advertise to both our internet service providers. Inbound optimization, how it's done. So RP does the probing for outbound destinations. Based on that, our developers created a statistical model, and they can actually see through different when there is a problem on a certain AS path. And based on that information, RP can detect where potentially could be a problem on the inbound traffic. For that, RP can do a particular action. So how to influence the inbound traffic to come through the best way. Um, this can be achieved with the use of traffic engineering capabilities offered by the internet providers. What are those? Traffic engineering capabilities are, long story short, a certain amount of route maps configured on the internet service providers routers, and based on what those route maps, they do different rules or apply do different actions. Usually those traffic engineering capabilities are triggered by so-called traffic engineering BGP communities. So StarNet offers a list of BGP communities with which our incoming traffic can be manipulated. So let's take, for example, BGP community traffic engineering will be 48.872.23. Based on the statistical model and the RP probes, we see that there is a problem with incoming traffic when it comes through AS23. RP, when it's triggered, it can actually send our prefixes tag with this BGP community, which is subsequently, sorry, let me actually do it this way. It will send our prefix with this community, and based on the route map on the StarNet side, they will completely stop to advertise our prefixes to a particular peer of theirs. So inbound traffic, inbound performance deflects the traffic from coming through the worst performing provider. It's either this or different traffic engineering BGP communities do different actions. So this is for not advertising at all to AS23. Sometimes they have BGP communities to start prepending to AS23. So it still comes through this one, but the probability that the incoming traffic will come through AS23 is decreased really high. So all the inbound traffic comes via other peers of StarNet instead of AS23 in this way, but not for here. What also I could mention, yeah, so this is pretty much the inbound performance optimization. It's not, it's semi-automatic. And why I mentioned that, because when it comes to inbound optimization feed, it's not just an enable button, it needs inbound performance rules to be configured. So basically it's a test inbound, oh, come on. Inbound rule. You select the provider. You use the traffic engineering markers belonging to those that they offered for your use. You set up the packet loss threshold. So let's say you see that there is a packet loss on the path, AS path 23.48872, then RP is triggered. Let's say 5% packet latency. You like 20, and then you need to set up the AS path regex. So it will be basically something like it was like this. Sorry. Twenty-three, 48872. And whenever the platform is triggered, it will send your prefixes with this particular traffic engineering community to Airtel IPT beer J58G, and based on their route maps, they will do a certain action according to the matching BGP community. Inbound optimization feed has two modes. It's either automated or moderated. So you can give all the inbound decisions to be done automatically by RP and applied without your consent. Or in moderated mode, you have to, there will be an inbound optimization feed. So you'll see here what kind of rules have been triggered, and you will have to approve RP to advertise that those prefixes of yours with that traffic engineering community. And that's basically all about the inbound optimization feed. Do you have any questions?
So for this, we need TE, right? Traffic engineering in our
Not you. Yeah, unfortunately, not you, but your ISPs
your
have
ISP.
to
Yes.
have to to offer those capabilities. If
So
they do
so
not,
we
unfortunately, yeah, it is not possible if they do not
so
offer
so
them.
right so right now we are connected to Tata, Airtel. So in that they have to provide us. So we have to ask
Yes.
them for that, right?
Yes,
Okay.
yes, correct. So far, yeah, Tata I haven't had before, but I know that Lumen for sure has, Cogent for sure has traffic engineering. Yeah, so far those two. Anything else, or can I go to black holing or threat mitigation? That's it. All right, I'll then go to threat mitigation. So since you've been here 1 year ago, only the manual DDoS was a feature of ours, but we updated that feature. We improved it a lot, and you can actually automatically trigger DDoS mitigation via RP. So monitor. This is a very handy. I think it's for the last 30 minutes. Yeah. Graphics, which shows you the amount of traffic based on different types of protocols, and which are pretty handy in order to detect what type of DDoS attack you have on your side, or with which type of DDoS attack you're being attacked with.
So how to know that detect? So from this graph, right?
Yeah, so different types of DDoS attacks use different types of protocols. So there is TCP SYN, I think, fluid. So it opens costly TCP SYN. It sends TCP SYN packets in order to occupy the the TCP queue, let's say. So basically, whenever someone tries to actually open a TCP session to your server, or a server which is in your AS, then it will be neglected because there is no available TCP connections. So this is TCP SYN fluid attack, I think. ICMP is ping of death. It's constant. ICMP will send massive volumes of just ICMP packets.
Yeah, I understand.
Yeah,
But
so there are different
what
types, and
my question is how we know that it's the attack from this graph?
oh, you will
How we
see
know
a
it's
massive, you will see a huge spike, believe me. Because here it has not only the amount, but it has the packets per second amount. So whenever a DDoS attack occurs, there is a huge increase. It depends. It depends on who attacks and how many are involved. How many zombie, well, they're called zombie hosts. So based on that, it will not be. It will definitely not be 16,070K packets per second. It will be hundreds of thousands, maybe even millions. So it will be just a huge spike.
Yeah,
But
but
mhm.
how we know that the source of that DDoS attack, something like that? Do you have that visualization here?
Unfortunately, we can do the DDoS mitigation based on the destination address, which is your
Okay.
destinations. Yeah. So, but let me cover that in a little bit in more depth.
Okay.
There are two types on how to configure threat mitigation. First one, well, let's say here are configured in mitigation rules are configured the exceptions from the default configurations for DDoS attacks. So here, sorry,
Am I audible?
here you have a threat mitigation. First of all, there is just manual.
Am I
This is,
audible?
sorry. Can
Yeah,
you hear
yeah,
me?
yeah.
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 Yes,
About
yes, yes,
this
yes.
threat mitigation, does it also shows some notifications, or
Yeah,
for
you can configure notifications, of course.
so if there is any threat, it notifies us?
Yes, as long as you are subscribed.
Okay, in the subscription.
Yeah. Should be somewhere around here. I think it's here. Let's see. An RTBH threat mitigation decision was added and activated manually, or an RTBH threat mitigation decision was activated automatically by the DDoS. Previously activated RTBH threat mitigation. So there is a list of different notifications that can be configured, and as soon as the DDoS occurs, you will be, of course,
So this will
informed.
notify whenever there is a action performed.
That when there is an attack, but those are based on the thresholds. So here I wanted to mention. So there is DDoS mode, manual, which means that you are creating the DDoS rules and you are operating them. Moderated, it actually means that our RP detects the DDoS, but in order to mitigate it, you need to apply the rule. You need to approve the rule offered by the RP. And automated, all of the heavy handling is done automatically by RP. So he just issues black holing rules automatically without your approval. Let's actually change this to moderated for now. Protected addresses. So, like I said, RTBH or threat mitigation is based on the destination of attack, which are your prefixes, but to be more precise, which are your hosts. Until recently, it was only the host, but actually you can detect the attack on a particular host, but issue a DDoS, an RTBH with a prefix. So this is protect analyze prefixes, which are added in here. Sorry, it's in collector. Close and save. So it will analyze this, the hosts which are part of these prefixes. Either you can set up RP to protect all prefixes. So it will not look at that list and it will just issue RTBH with any destination host that is being attacked, which is even out of a list of analyzed prefixes, or maybe if it's not added in the analyzed prefixes, or maybe it's a downstream of yours, which is not analyzed by RP. So basically the RTBH will be stopped at your edge routers and it will not go to a customer or a downstream of yours. Black hole thresholds in kilopackets per second. So here you set up, just like I said, the default configurations, and there is the exception from this default. Here you set up black hole threshold for all of the prefixes, which means that if a certain host, and I mean host /32, registers an amount higher than, let's say, 80,000 kilopackets per second, then an RTBH will be triggered and issued. But here's in a moderated mode, which means that you will need to approve it. You can leave it like this and just hit save, but you can also set up additional rules which will be used as an or condition, alternatives. Now I found the right word. So the black hole will be issued either on 80,000 kilopackets per second, and you can set up here 8 gigs. So either this, or you can even set okay, for flow spec it should be lower than the black hole, and I'll explain it in a second. So whenever either of these conditions will be met, RTBH will be issued. Like I said, mitigation prefix size threshold is applied for a /32. By default, it will send a BGP update with that /32, but this behavior can be changed. So if a host is attacked, you can actually send an RTBH rule as 31. So a particular range of prefixes will be mitigated, not only the host. Also, same thing applies for IPv6 default BGP reaction. So you can, by default, it's a drop. It sends a drop BGP update, but you can actually set up as well. Maybe you have in your AS a scrubbing server, which is used for DDoS mitigation. So in this case, the traffic will not be dropped at your edge routers, but it will be redirected to that server, and the traffic the entire traffic with the valid traffic and the DDoS will be scrubbed by the scrubbing server, if you have one, which is used for DDoS. Same with a flow spec, BGP, redirect routers. Here you configure the routers to which you would like, in case of a DDoS attack, the traffic to be redirected to. Flow spec same applies here, and BGP redirect communities. If you would like to tag the BGP rules or the BGP updates with a particular BGP community, you can do it here. You can add it here. This thing can be also configured per provider. Oh, sorry, this is BGP redirect actually. It's not BGP. It's not DDoS community. Timekeep, which means that for when a rule was triggered and was applied, either in moderated mode, so it was approved by you, either in automated mode, that rule will be kept for 1800 minutes, unless you go and manually remove it from RP in the section that I showed you previously. Time monitor, which this means, so this is the amount of time in during which the DDoS has to constantly occur. So if a DDoS occurs for 3 minutes, for the entire time of these 3 minutes, then the rule will be triggered. You can change it up to 2, I think, but you better leave it for free. And in 3 minutes, if you have a DDoS attack, the rule will be triggered. Whitelist. So as mentioned, you have sometimes protect analyze prefixes. Maybe you wouldn't like all of the prefixes to be protected. So you can here write a list of prefixes that you like RP to ignore for DDoS mitigation. Okay, this
Just,
is the okay, go ahead.
No, just the last one. Can you just explain what that manual automated is okay? Moderate, just moderate mode, something like that.
Manual is you go
Just,
here, you go here to mitigation rules, and
uh-huh.
in case you would like to DDoS, sorry, to black hole a destination of yours, then you just go here and it's here. You see, it's
Yeah, okay,
manual
okay.
mode
Yeah,
only.
yeah. Only.
Yeah. So it
Then
will not allow
moderate.
you to configure anything rather than manual. I can actually safely change it here to moderated because it will still do nothing without your approval. Just to show you the configurations that are also done on the RP side.
Yeah,
It's,
but
you
how
have
how it
to
works? Moderate mode. One is
moderate it.
manual. Yeah. How?
Let me just hold on for a second. Okay, configuration saved. Sorry, reset. Moderated. So moderated, whenever a DDoS occurs, there will be here. The rules will automatically appear here. So you'll have to. There will be a button. You'll have to approve. It will show
Okay.
you which, the status. On
And
which type of protocol on which instance, because this is GMI, so it can manage multiple instances, which host is being attacked, so which address of yours is being attacked. /32 will be here. Mitigation mechanism, I will discuss it shortly. Reason, when it was detected, when it was enabled, and when it will be automatically disabled. In case it's moderated and
moderate mode.
automated, or automated because there was the timekeep parameter that I mentioned before. So here I changed to moderated. So here you have a moderated and automated mode. So if you do not configure here anything here in mitigation rules, RP will use the rules, so we'll use the parameters configured here. In case you would like to do something more specific, or then the mitigation rules, this section is for you. So here you add a rule, you would like to maybe initiate a manual DDoS, And here kicks in the two different mitigation mechanisms: BGP black holing and
Redirect.
yeah, BGP redirect. But just a second. Yeah, unfortunately, I will not be able to show on your own instance, but give me 1 second. I think it's on our instance. Is it configured? Is configured. Good. Because there is two other mechanisms. So here it will look something like this. You see, if it's in moderated mode. He thinks that we have a DDoS attack, the black holing dropped mitigation mechanism reason when it was detected, and yeah, it's in moderated mode. So I either have to hit accept or remove the rule. Mitigation rules, I think here should be, okay, let me manual moderated. Okay, here other yeah, it's because you don't have a flow spec capabilities enabled in RP. That's why you don't have all the options. But if you will configure the IBGP sessions with RP2B with flow spec capabilities, you will have also these options here. So yeah, let me discuss here. Like I said, BGP black holing, it goes to your router, and there is a null route on the router which discards the traffic, which drops the traffic in case of it, or a BGP redirect if you want your router to shift the traffic to the scrubbing server.
So yeah, we need to, do we need to go into router and configure null route there, or this BGP black hole will do this, those things, those? Do we need to configure
No, you
null
need
route in?
you need, yeah,
Just
you need to configure a null route. Yeah,
null route.
it's yeah, IP route, some next hop which is going to null route. Can be anything, and we can
Or it
and we use that next hop, and we use here, we give the
destination prefix.
sorry, yeah, the prefix, but we configure the just a second, it's here. So for black holing, we here, you see,
Okay.
announced black holing local pref, I even forgot to mention, and black holing IPv4 next hop. So this next hop should be routed. You should add a static route for this next hop to be routed to null. So whenever RP is sending a route with that, yeah, with that next hop, the traffic will be dropped.
Okay.
So let me, where was I? Instance moderated. Okay, BGP black holing. BGP makes sense. Flow spec drop. You can configure RP to actually use flow spec capabilities to send a flow spec drop or flow spec redirect policy, and RP will automatically send it in case it's triggered. Or you can use a combination of those two. So flow spec drop on BGP black holing, how it works. Okay, the logic behind it. For flow spec, the rules can be sent only to your routers, and the rules can be applied on your routers, because usually it's the flow spec capabilities are configured only within an AS. It cannot go via an eBGP session. Oh, it shouldn't go. It's just rules of logic. But this means that flow spec drop is happening at your edge routers. Sometimes when a black holing occurs, even with the flow spec capabilities, the DDoS still hits the server. In this case, RP does first the flow spec drop, and it has a configured threshold. They have two different thresholds. So first, the flow spec drop is being sent to the router in case that doesn't help, and the second threshold for BGP black holing is being hit. RP sends a BGP update in this case, or issues an RTBH, a remotely triggered black holing. What is the logic behind that? So flow spec happens at your edges, but with BGP black holing, you can actually tag the BGP updates with the black holing communities that are offered by your providers. So you can actually send re-advertise those BGP updates to your providers, and they will stop dropping the DDoS traffic. Let me remember 83.0/24. If you don't configure anything here, treat prefix as, it means that it will treat this prefix as, it will initiate black holing rules as a /32. So here, as I mentioned, so first the flow spec kicks in black holing. If it doesn't work, the black holing kicks in. So here you can, let's say, bits threshold, megabytes per second, gigabytes per second. So here, the flow spec amount will always, value will be always lower than black holing, because first it's keep the rule. So if you don't give a value here, it takes from the general configuration that I mentioned before, and as you, when you click save, you will have here a rule. It will show you when at which amounts of traffic the platform will be triggered. Here, when it was added by user, in case you have multiple users on your instance. So let me see if I mentioned, if I forgot to mention before. Okay, so in your case, you will not have a history, but we have here a history of DDoS. It was triggered by a platform. Of course, we put just these values to trigger something, because we do not have like a huge amount of traffic in our office. But in case the DDoS attack occurred, the RP has done some actions, or even if it didn't do, but all the mitigation feed here will be also shown here on in the history. So you keep track when your ASB has been attacked. And I think that's about it. Do you have any questions?
Regarding this DOS protection, so it is for layer 3 and layer 4 DOS attacks, right?
Sorry, say again.
Just a minute. So regarding this DOS threat mitigation part, so it is more specific to layer 3 and layer 4 DOS attacks, right?
Layer 3, because
Layer 3.
Yeah, because the IP address is being black holed. At the moment, we do not have threat mitigation via flow spec, which drops the traffic on particular ports or particular protocols. But this can be done only manually. Eventually, this will be improved, of course. So here, source port, where it is. So destination port policy enables DDoS. Let's say it's better if I do it on our site. Can't remember your your ranges. It's okay. Close back. Come on. Let's say 32. Policy nodes DDoS. Oh, my bad. source port, we will leave it as it is. It doesn't matter from which ports it's coming because there are just random destination prefix. Sorry, this shouldn't be here. It should be here. Let's say port 80. So basically, if I give it 8, or even multiple ports can be configured. So here, and you would like to drop traffic only on these ports. Create a drop policy, and as soon as you hit save with flow spec, it can drop all the traffic coming to that particular address that I typed in here, only on TCP and only on 80 in port 443 as, yeah, actually it should be destination port. Okay, yeah, this is destination port. I'll talk with the devs. They missed this one, but yeah, to these destinations will be dropped. To any other ports to these destinations, they should be allowed, and UDP and ACMP traffic. So it can be done, but only manually. Any other questions?
Not from my side. Anything, any questions? So let's just come in. I think
Let's see our Nepal Telecom dashboard. There's one issue, I think.
Yep.
In the dashboard,
Mm-hmm.
in the instance status, if we click on the LO.
Sorry, say again. You are
not in that on the or
Yep.
if you
Sorry,
click on
you're
the
cracking,
instance
yeah.
name.
Mhm.
Yeah.
Yep.
Yeah.
in yellow.
LO. Yes. If you click on that.
Yeah, because it's the local. It's okay. So RP is installed on the same machine as
No. Let
as the RPGMI. Yeah.
Let's have a click on that LO.
Okay.
In the status, this one. Can you scroll down? There is unknown state in the slave config synced or not. What's that unknown? I think it's not clear, right?
Mm-hmm. It shows the yeah, it shows the status of synchronization of the RPConf file. We know about it. Yeah, it's the failover status bar was recently added, so yeah, we're working on it. But actually, it's synced.
So it's synced, but it's showing unknown.
Yeah, it's showing no, and we know about this bug.
Okay. Okay. Thank you.
Anything else?
No, I think it's
No, from my side.
yeah,
Not from.
yeah. Thank you. I think it's very extensive because we haven't been through this training on this IRP. So it's something like training, or so it's very.
Well, it was more
thank you.
in more detail. It took like a couple of days, but yeah, it was even more detailed.
Yes.
I tried to narrow it down as much as I could.
Yes, but just one suggest, not feedback. In your previous dashboard, here we can see something like that, current traffic average, something like that. In just go below this graph, just move
Graphs?
down.
Oh, well, or you actually mean to scroll down?
Yes, scroll down. Yeah, not this one. Graph.
Oh, you mean graph? Okay, yeah.
Graph. In dashboard also you can see. or somewhere. No, any graph, some traffic or something like.
Mm-hmm. Let's try
Any graph.
something like performance.
Yeah.
Yep.
Yeah. In previous dashboard, we can see here that current something, some count also, not only legends like this, but some counts also in previous dashboard. But here we have to go move the cursor and then check the counts and everything.
Yeah.
Yeah, in previous, I think old one, we can see below the graph some count also.
Oh, so you mean this one?
Yeah. This is okay, but aside by
This
this
is the legend, yeah.
Yeah. No. This is legends. Okay. So we see there in your previous dashboard that count also, that some counts, current traffic, average traffic, or something like that, minimum, maximum. That was also helpful. Some.
Oh, you mean in the old front end?
Old one, yes, yeah, front end. That was also helpful. But right now we have to move cursor and then see the traffic and then counts. That part of previous graph was also good.
Which exactly graph in the old one was very helpful?
All the graphs, I think.
Let me see.
Yeah. In dashboard also you can see here, no? Just old dashboard, old one.
Yeah, give me one sec. Performance improvements, where it is.
Any graph.
Oh, performance improvements.
You can yeah, average, max, mean. That was also helpful, I think. Yeah.
Understood.
Yeah.
Okay.
Yeah.
So you would like to add also those to.
That was also good. I think the good view. Yeah.
Okay.
Just feedback. Otherwise, it's okay. Okay, thank you. Okay, Nishiji, okay, collect the one. Hello, Nishiji. Pavin jab त्यो क्लोज गर्दा हुन्छ नि
ए हजुर
ठिकै छ सर
I think we have a very informative and extensive knowledge. This session is brief for us also, and
yeah, I mean,
so,
in short time, Oleg was able to deliver pretty nice. So I like that. So thank you very much, Oleg, and
so we can I think close now. Thank you, Oleg. I am from Nepal Telecom, and we and our team just thanks you for your good,
You're
presentation.
Welcome. Okay. Yeah, I already had experience with doing a training with your company, so.
Yeah.
Okay.
So
okay,
all right,
then.
I wish you a great day ahead to everyone. I will send the recording to you after the meeting. It will take some time to Zoom to generate the link, but I think in 30 minutes, 1 hour, it should be. I will share it with you. So in case you need someone to review the recording, is no problem. All right then. Like I said, have a nice day ahead. Take care.
Thank you, Oleg.
Thank you.
You're welcome.
You too. Thank you. Thank you, Oleg.
Thank you.
Thank you.